Okay, everyone, so we're going to see the last of the processes. Okay, we're going to see now translation. Okay, translation is going to be sequential. Okay, so we're going to use several different elements that I'm going to highlight right now. Okay, elements in translation. Um, okay, here. Elements. Okay, there are going to be several molecules and several enzymes. So the first thing that we're going to use obviously is RNA. Okay, and I'm going to paint it with a nice red. Okay, RNA that is single-stranded, as you know, and has several differences with the normal usual DNA that we know. Then we're going to use tRNA. tRNA that, if you remember from the transcription video, is something like this. Okay, this is going to be tRNA. I've said mRNA, but I haven't painted the mRNA. Okay, mRNA and tRNA. You remember also that mRNA has the codons and that tRNA has the anticodons. Okay. Codons and anticodons are sequences of 3 nucleotides. Okay. 3 nucleotides. Okay. That are going to have a special relationship between themselves. We're also going to use amino acids. Okay. To build proteins. Okay, several amino acids make a protein. Okay, several hundred or several thousand amino acids make a protein, and then we're going to use something that is called the ribosome. Okay, here, the ribosome. Okay, and the ribosome is going to have 3 sites and 2 subunits. Okay, so this is a ribosome. It's going to have a big subunit. Okay, here. And then it's going to have a small subunit. Okay, and in the big subunit there are going to be 3 sites, and that is going to be the exit site, the amino acid site, and the enter site. Okay, but we're going to see them in. It's going to have 3 sites. Okay, A site, B site, and E site. Okay, and that's going to be the difficult part. Okay, but don't worry, because I'm going to try to make it as easy as possible. Okay, so translation starts with one that we're going to call initiation. Okay, in the initiation process we're going to start the whole thing. Okay, first of all we're going to join the tRNAs with the amino acids. Okay, we're going to call it 1.1. Okay, tRNAs plus amino acids. Okay, and we're going to obtain something that is called the amino acyl tRNA. Okay, amino acyl tRNA. That is going to look like this. Okay, there's an enzyme, the amino acyl tRNAs. You don't need to remember that name, that's why I'm not reading it down. That joins in the anticodon with the amino acid that is supposed to go with that anticodon, because there's a code, okay, that every living thing uses that relates that has a relationship between the anticodon here and the amino acid here. Okay, so the amino acyl tRNA. Once we have lots and lots and lots of amino acyl tRNAs floating around, then the process is going to start. Okay, how does it start? In the poly A tail. Okay, this is going to be the 3' poly A tail of the mRNA, and then we're going to have the mRNA proper. Okay, so this is going to be the 3' end, and this is going to be the 5' end. Okay, so the small subunit of the ribosome comes here, okay, recognizes the poly A tail and locks here. Okay, this is going to be the small subunit, locked here, and starts scanning the mRNA until it finds it starts scanning in a towards the 5' end. Okay, so it starts scanning until it finds the start codon here. For example, it's going to be here. This is going to be the start codon. Okay, so this happens while the amino acyl tRNAs are being joined. Sorry. So it scans and then it's going to stop here. Okay, it's going to stop here. I need to put in both colors where it stops. In the start color. Then it comes 1.2. In 1.2, okay, we have this here, poly A tail, and we have our mRNA molecule with the start codon. Okay, then we have the small subunit like this. I'm going to draw it a little bit bigger, and you have to take into account that there are going to be more codons here. Okay, you need to separate them so you can recognize the codons, and I need to do several of them like this. Okay, and at the end it's going to be the 5' cap. I'm going to paint it orange. Okay. Then now the small subunit has found the start codon here. Okay, so it calls the big subunit, and the big subunit is going to join here. Okay, like this, with the three sides different places. Okay, so to make the process a little bit shorter and be able to draw everything here, this is going to be the start code. Okay, this one here is going to be our start code. Okay, so the big subunit, okay, so we leave it there. Okay, now we have the ribosome assembled. Okay, we're going to call 1.2 ribosome assembles. Okay, then we have 1.3. Okay, 1.3, we're going to have again our poly A tail, then we're going to have our molecule of mRNA with the cap, and then we're going to have our codons, this one is going to be the start codon, okay, like this. I'm going to highlight the start codon, okay, with a little bit of black. It's not that it's different, but I want you to see where it is. Okay, I want you to see where it is. Sorry, I haven't said the sites. Okay, this is the A site, B site, and E site. Remember here, A, P, and E. Okay, so they are located like this. A site is the amino acyl. Sorry, in English is with a Y. Amino acyl site. Okay. E is called. This is A. Peptidyl site, and then exit site. Okay, important that you know that. So this is going to be the A site here in the start codon, B site, E site, then the big subunit and the small subunit. Okay, perfect. In 1.3, the amino acid tRNA that belongs in that is complementary, sorry, to the first codon is going to enter here. Okay, like this, because the sequences between this anticodon and this codon are complementary. Okay, and it's going to carry an amino acid. Okay, you're going to have a presentation about how this works. Okay, the codon anticodon system. You're going to have a presentation about it. Okay, but the start codon is always the same. Okay. So the first amino acid is going to be methionine, okay? Then we can eliminate it or change it or whatever, okay? But every sequence, everywhere, every protein at first starts with a methionine amino acid, okay? So this is the final part of initiation. Now we're going to go to step number 2, that is called elongation. in elongation, we're going to make the amino acid sequence bigger. Okay, how do we do it? Super easy. Okay, so we're going to start from here. Okay, so this is the poly A tail again, mRNA sequence. We have several codons. Right, we're going to keep it to 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, and then we have the cap. Okay, and remember that our start codon is going to be this one here, a little bit highlighted. Okay, so now the ribosome is going to move, and it's going to move towards the 5' end, this one here. Okay, so the ribosome is going to move. Okay, this is going to be 2.1. It moves, so the first amino acid tRNA goes to the peptidyl site. Okay, this is super easy, but you have to pay a little bit of attention here. The first amino acid goes to the here, to the P site, to the peptidyl site. Okay, like this. We're going to put this one here. Then another amino acid is going to come here, okay, complementary to the codon that is in the A site now, okay, like this. So it's going to enter. And this is going to be amino acid number 2. Now step 2.2. Okay, we have the same stuff. Sorry if this bothers you, but it's more useful for me to do it like this and for you in the long run. But it's a little bit, I know, it's a little bit boring to see me draw all the codons. It was 7 of them, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. It's super boring for you to see this every time, but it's I believe that it's necessary. This is going to be the start codon, so you keep it located, and then all the 3 sides here. Okay, now what's the difference between 2.1 and 2.2? 2.1 and 2.2, so we're going to have tRNAs here with number 2, number 1, and something is going to happen. A link is going to form. Okay, this is called the peptide link. And it joins one amino acid to another. Once the peptide link is formed, okay, the connection between the tRNA and the amino acid is going to be broken. Okay, so this connection is going to break here. Okay, and then the amino acid number 1 is only joined to amino acid number 2. Okay, So amino acid number 1 and amino acid number 2 are joined like this. Okay, so we skip to 2.3. Sorry, this is a 3. Again, now the difference is that the ribosome is going to move again, okay, towards the 5' end. It's going to move towards the 5' end. Again, codons, okay. This is the start codon, okay, and now it's going to move. So this is going to be exit site, amino acid site, and peptidyl site and amino acid site. Okay, this is going to be the big subunit, small subunit, and now we're going to put our usual suspects. Okay, this is going to be tRNA1, this is going to be tRNA2, and then another tRNA is going to come here. That is going to be tRNA3. Okay, amino acid number 1, as you remember, is only joined to amino acid number 2, and not anymore to the tRNA because of the peptide link. And now we're going to repeat step 2.1 here. Okay, we're going to form the peptide link, and this is going to break. Okay, so when we get to step 2.4, okay, to the next elongation, and the ribosome moves, sorry, this is not the color, this is the color for the mRNA, and the ribosome moves, then you see what is going to happen. This is going to be, as usual, I need to highlight the start code so we don't lose sight of this. Inside, A site. Okay. Unit. Then what happens? Again, one amino acid tRNA is going to come here, okay, and this one, the first one, is going to come out from the exit site. That's why it's called exit. The tRNA is going to be reused, okay, for something else, okay, to make. It's going to go to the amino acid tRNAs to be joined with another amino acid and blah blah blah. So we're going to have more. We can recycle. Okay, so 1, 2, 3, and then we're going to have a 4. Okay. I painted it too small. Sorry. This is not going to be joined, this is not going to be joined, because remember that we're going to form the peptide link here, and this is going to break. Okay, so this is the elongation process. Okay, at the end of the elongation process, in this one, we're going to have a big chain of 4 amino acids. Okay, normally it's hundreds of them. Okay, it's hundreds of amino acids to form a protein, but here, I mean, we kept it short. And then we're going to 3. there is termination. Okay, termination is finishing. Okay, in 3.1 this is going to be like an elongation. Okay, we're going to move our RNA molecule, our ribosome, towards the 5' thing, to the 5' cap. Okay, but instead of putting another amino acid tRNA, we're going to incorporate something that is called the termination factor. Okay, that I'm going to draw it in purple. Okay, the termination factor is going to enter the amino acid site. Okay, so we're going to have here one tRNA that comes out. Here we're going to have, this is going to be 4, 3, 2, and 1, 1, 2, 3, 4. Okay, and then as I said, the termination factor comes in. Okay, obviously there's going to be an anti-codon here for the termination factor. Okay, this is going to be the anti-codon for the termination factor, and remember that our starting codon is here. Okay, now when several things are going to happen in 3.2, so I'm going to draw all the stuff bigger than normal. Okay, so we can look closely at it. Okay, so this is going to be bigger than normal, so we can take a closer look. Remember, this is going to be our start codon, and this is going to be the termination codon. Okay, that codes for the termination factor. Now, here we're going to have the A site, B site, E site, and big and small subunit. Now, remember that we have in place here the termination factor. Okay, so when the ribosome tries to move, okay, it's not going to be able to move. It's not going to be able to move, okay, because there's the termination factor in place. When the amino acid here tries to make a peptide link, okay, there's not going to be anything here, so it's not going to make the peptide link, but the connection here is going to be broken again as normal. Okay, so we're going to have a free floating chain of amino acids, and here we have the other one. Okay, so the ribosome is not going to be able to move, okay, and the sequence is going to be free. What's the end thing here? Everything is going to disassemble. Okay, everything is going to disassemble in 3.3. So that's basically okay. I'm going to add brief descriptions here okay, for elongation and termination, and then you will have the finished video. Okay, so now that everything's written, quick recap. Okay, here we have the initiation, the small subunit scans for the start code and stops there. Okay, and then the big subunit enters the big subunit joins and calls for the first amino acid tRNA. In elongation, the ribosome moves, another amino acid tRNA is joined, enters the A site and makes the peptide link or peptide bond here, okay? Here, okay? And then the ribosome moves again. This keeps on happening all the time, okay? And the chain is elongated, okay? When the tRNA runs out of sites in the ribosome, it exits the ribosome, okay? And the ribosome moves all the time. When the termination codon is found, the termination factor enters, okay, and then the elongation stops because there is nothing to elongate with. There is this one here, there is nothing to elongate with, so it just finishes and disassembles. Okay, so this is translation. It's easier than it looks, but you have to take into account everything that is written here, and you have to study it and see the sequence of the ribosome movement and everything. Okay, so that's it for now. I hope that you enjoyed the translation, and then you have to see the next presentation that is going to be about the genome and the mutations. Okay, and that's it. Hope you've enjoyed it, and if you have any doubts, you know the usual means to ask me. Okay, find me, ask me, and I will happily solve any of your doubts. Thank you very much. See you in the next video.